Hello to everyone and welcome to another Adventure Story Channel video. Today we will discuss, as you can see here, a investigation report. And what is this investigation report? This letter will talk us about some case, okay, and analysis in this case, and we will see a route, okay, how we investigate a accident or damages, something like that, okay. And this kind of investigation reports you can find in some companies. The companies send them every time on board. Good companies, they try to show to the personnel, okay, what is the proper solution, okay, and how they will be alerted about any troubleshooting and other situations which can you see on board, okay. First of all, I'd like to thank you that you are staying with Adventure Story Channel, and this investigation report I found also in some files of the ship, and I was really interested to share with you that one because this is a very detailed situation, okay. We have the vessel name, we have the date, the year, we have the investigation subject, which was air condition compressor in broken status, okay. We have the main investigator, we have which position is it, technical manager, okay. But most important, I like here today to stand in details, okay, how we take the incident, okay, in the first hours, okay, what we do, the first steps, what we do, okay. Let's see one by one. We have the data of air conditioning plant, we have the shipyard, Sangdong shipbuilder. This is Korean made. Most of the equipment of Korean made ships is Sangdong. Hull number, okay, every ship have its own hull number. Classification, okay, classification ABS. Air conditioning and ventilation plant maker, High Air Korea. Compressor making Bock. Compressor type, you have number of cylinders, bore, stroke, speed, RPM per minute, and cooling media, which is Freon R407C. Okay, let's see the description of the incident. Air condition compressor, okay, breakdown after 2176 hours. And what we can see here, okay, of continued operation, they must be changed on basis, okay, on monthly basis or like that something. And 2000 hours, okay, continued operation, it's quite a lot of time, running hours, because okay, sometimes compressor starts and stops, it depends, okay, maybe it was working completely continuous. Okay, let's continue. During running operation, the compressor noise changed, but the crew did not stop it, and the compressor after 8 hours stopped from overload, okay. The crew could not start it because the motor which drives the compressor was always in overload status. After cylinder cover dismounted, they found that the valve suction discharge were broken, and the broken valve parts inserted in the compressor chamber and defected the pistons and the cylinder unit surfaces. Okay, the valve was broken, they entered the compressor chamber, make damages to the surface of the piston and cylinder, okay. The first step that the immediate cause which crew must do is, if any noise is observed, and it's different that you listen every day. That's why we make around morning time, also evening. And if you listen some abnormal noise, it's better to inform someone, some engineer, second engineer or chief engineer, and it's better to stop to investigate the cause. Okay, the immediate cause: compressor suction discharger valve breakdown and has a result to damage and block the compressor pistons and destroy the cylinder unit's surfaces. Okay, basic cause: suction and discharge valves damage because of liquid freon rich in the suction valves area. Okay, as we know, in the compressor side, from the suction side, okay, the valves must suck the freon in air phase, okay, in gas phase, never liquid, because they will broke. So lack of control means insufficient oversight of activities from design to planning and operation. Inadequate system standards: the maker, in order to ensure the safe compressor operation, installed in the AC plant the following safety device and equipment. Okay, as you know, all air conditioning plant, refrigerating plant installed with safety device. Okay, in order to find how the compressor was broken, I inspect and check all the safety devices and instruments which the maker uses for protect the compressor, and my results are the following. Safety device, okay, high pressure transmitter, breaking in case of too high pressure in the compressor discharge pipeline, cut in 22 bar, tested and was found in proper value. Low pressure transmitters, breaking in case of too low pressure in the suction compressor lines, cut in 4.5, cut out low alarm 3.4. The transmitter tested and activated successfully in these two valves. Okay, as you see now, the low pressure was tested, was good. The high pressure also was tested, was good. But why this was not really protect the compressor, okay, from breakdown? This is the main purpose, okay, because these transmitters receive only pressure, okay, they cannot understand in what phase is the freon, okay. This is the point, and if the pressure is okay, they will work without any interruption. Okay, let's continue. Oil pressure control breaking in case of falling oil pressure in lubricating oil system, cut in low alarm 1.5, tested and was found in proper value, also good. Lube oil pressure was good, was not activated, nothing to do with freon, okay, oil. Suction temperature sensor type PT100, breaking in case of too low gas temperature in compressor suction line, low warning 6 degrees, low alarm 4 degrees, and high warning at 35. Tested and was activated successfully in both values. Okay, suction temperature sensor. And now, as we can see, all the safety devices was activated successfully in both and was tested, everything. Safety equipments, okay. There is a oil separator, okay, location in the discharge line after compressor. Purpose: separate the freon from the compressor oil and return the oil to the compressor crankcase. The oil separator dismantled, cleaned, inspected, and was found in proper operational condition. And there is another safety equipment, which is liquid separator accumulator, okay, which location is in the suction line and before the compressor, The purpose is to stop undesirable amount of liquid freon to reach and damage the compressor suction valve. Okay, this is the main purpose of this liquid separator. The liquid separator, okay, we have also with red letters, was found insulated from the shipyard personnel with strong foam insulation around. Okay, as you can see here, these pipes in the image. This is a very big mistake. This means that this device was out of order because the liquid separator, this separator here, accumulator separator liquid, uses the ambient engine temperature in order to convert the saturated gas freon into dry gas and avoid any liquid hammering effects in the compressor suction valves. Okay, these pipes must be not isolated. Also, I have not seen in my previous ship that was isolated like that. And also here you can see. And now we will see how this liquid separator look like. Okay, both liquid separator covered with foam insulation and converted in one simple pipe. Okay, the saturated coolant gas inserted to the gas separator. Okay, here this is the gas in, the gas inserted here, and the drops of the gas lose the speed around here. As you can see, the diameter of the space is bigger. Okay, and the accumulator absorb temperature from engine room, from ambient temperature, and convert the saturated gas in dry gas. So you can see, even if the gas going here, okay, it have holes here. Okay, as you can see, I will make a zoom. Here you can see it's holes diameter. In the case that if some gas it convert to liquid, again here will drop and fall down here. Okay, so the gas will flow like that. Here will remain gas, whatever drops will be trapped here. Okay, and the gas will go to compressor, to the suction valves. So they have a insulation here form. That's why the ambient temperature of engine room cannot convert the saturated gases to dry, and that liquid enter inside the suction valves of compressor and make a hammer effect inside and broke the valves. Okay, and then we have the conclusion. Okay, what to understand from that problem: incorrect installation. All the foam insulations must be removed from the liquid separator. Okay, from here, this one here and here, which shows the arrows. Design failure. Liquid separator size is small and not effective. This is some design failure. Always you need to observe, to check after you read the investigations. Okay, level indicator. This is also very important to know. Glass, because there is a level indicator glass in the freon condenser, is not the proper in case that the freon level is high. The crew cannot check it and confuse the high level with low level due to cooling liquid crystal clear. Okay, white color. The cooling liquid really is so clear, and if there is no any floating balls, okay, you cannot determine proper the level. Okay, and sometimes these balls can stack up also. You must have a nice flashlight to check exactly where is the line of the liquid, okay, and where is located. Okay, and after, as you can see here, after compressor breakdown, the air conditioned condenser was found full of liquid freon, incorrect handle after incident, inadequate management and control from the crew in order to minimize the damage, after first sign of broken valves. If the compressor stopped at once during the noise appearance, the damage will be minimized only to the valve plates and not to the piston and compressor cylinder units. Lack of knowledge in air conditioning operation. The crew must increase his knowledge regarding air condition operation in order to avoid the following undesirable situations during AC operation. And here we have a Molly diagram in which you can see the absolute pressure here in this side and the enthalpy kilojoules per kilos here. Okay, we can see the saturated vapor here. This is the critical point. Okay, this is the saturated liquid, and we have the quality also and temperatures. Okay, it depends what temperature you have, what quality you can okay, this is for learning purposes. Lines, specific volume. Okay, for R407C you can use this Mollier to see what you have. You have saturated liquid or vapor. Okay, it depends the pressure, the temperature, and you can see the quality. Okay, and let's see here. Do not pass pure liquid coolant through the compressor suction valves. This is very important. The suction pressure and temperature to be kept within maker limit. The pressure and the temperatures, it's very important, because if the temperatures will be not kept within the maker limits, situations like that will occur. Okay, the gas will change to liquid, and then we have breakdown of the suction valves, or something else will happen and the freon will change some phase and the system will not work properly. If large quantities of oil to be topped up, there are risk of oil hammering effects. In case, check the oil return. Okay, also never increase the level high. Okay, this is also not recommended. Keep your level at normal level. Particularly, the air conditioning plant must be inspected, and is recommended the replacement of liquid traps, solenoid valves in the line, etc., if are not in proper condition. Okay, also there should be no movement of coolant whenever and while the compressor is at a standstill. This is correct because when the compressor is standstill, the valves is closed and there is no movement of coolant. This is correct. Correction actions. Okay, remove all installations from the liquid separators. In case to have any other incident in the future, must inform the maker to improve the liquid separator accumulator performance. Must be improving the engine officers and crew knowledge regarding air conditioning plant, always to operate properly and safe. And it's very important air conditioning operator to know Mollier diagram for understand the liquid and gas phase of air conditioning plant. So we have learned a lot of things here, I think, and the first thing that you need to do, okay, sometimes it is impossible to stop the machinery even if the breakage occur at that time we are there, but if we can, we stop. Okay, we investigate the case and we take the proper measurements, we look, we read the book, and we continue. Also, I had to say that, as you can see at the top, okay, just imagine this compressor is speed is 1433 rpm per minute, okay, and per second divided by per second, and you will find it's still quite a lot per second. Already the compressor, even you listen now at this moment and until you will stop, there will be some RPMs already, okay, done. That means the problem already will occur, but we will try to avoid whatever we can, okay. Thank you for watching. I will try to make more videos, more interesting videos. Stay tuned to Adventure Story channel, check my previous videos. Thank you, bye bye.